Good morning, ESM 102 students. This week we're going to talk about energy in all its forms, renewable and non-renewable. And I apologize for the sound of my voice. I have a cold, apparently. So this graphic, although slightly dated, gives you a good overview of where the world and the United States, um, where we're getting our energy from. And as you can see by that gray circle around both graphics, the lion's share of energy is all from non-renewable sources, rather. Um, the majority of which, in both cases, for the U.S. and for the world, is oil. So crude oil, including gasoline, diesel, fuel, um, all kinds of heating oil products, all of that. So, and then if you look at the orange sliver, it's a pretty small slice of the pie. It's 8% for the world and 7% renewable energy use for the United States. And so we're going to talk a little bit about what comprises all of these things and what the downfalls of the various fuel and energy options are. And this is just a good graphic showing kind of the exponential growth of energy consumption since 1800. And for those of you familiar with your history, the Industrial Revolution was, mid 1800s, and that's really when, as you can see, the red line here, coal started taking off. The blue line, biofuels, wood, and charcoal, was actually stayed pretty stable over this time period, but coal really took off in the Industrial Revolution, and it wasn't really until 1900 or so that crude oil and natural gas took off as viable energy sources. But as you can see, the top of this chart goes to 150 exajoules, which is about 25 million tons of oil. So uh, that's a lot of energy, and there's really not. This ends in 2008, but I'm imagining these lines are probably off the chart at this point, and will probably continue to be for some time. So, advantages and disadvantages of fossil fuels. First of all, just to define a fossil fuel, essentially it's oil that was created through the compaction and heat and pressurization of fossilized plant material. And so it took millions of years to make, and that's why it's a non-renewable energy source. Once we use it up, it could be several million more years before there's enough time and energy in the Earth's crust to make more. So obviously, waiting to make more fossil fuel is not an option. Um, but at the moment, it's actually there's enough oil to be had, and natural gas and coal is actually fairly abundant. The downside, of course, is air and water pollution. Coal strip mining is a big problem in not just in developing countries, but if you were to look up Appalachia in the United States, you would find huge devastation to ecosystems because they essentially destroy mountains and strip them clear of forest cover, and then all of that rubble goes into streams and valleys and causes water quality issues. And then obviously the biggest thing is greenhouse gases. When we burn coal, when we burn gasoline, we're contributing carbon dioxide. When we burn natural gas, we're contributing methane. All of these greenhouse gases contribute to what we now know as global warming. So, dependence on oil. Um, as you could see from that initial pie chart, the United States is extremely dependent on oil. And it comes in the form initially of crude oil, and we were actually extracting it at a pretty rapid rate, but the highest rate was in 1970, which they refer to as Hubbard's Peak. And so, as a result of the fact that we don't make enough oil to sustain our own use, we have to transport it from other countries, namely the Middle East. There's a lot of energy that goes into refining that oil. And then petrochemicals is kind of another use of petroleum. It includes fertilizers, pharmaceuticals, things like that. This shows a graphic of the distillation process and the refining process for oil. So if you can see when they cook it and they boil it, the lowest boiling point is at the top, and that's where the most refined forms of oil will be. So like car gasoline is one of the most refined forms. And then at the very bottom, where there's more components that are not taken out, you'll see uses like for asphalt and for grease, solvents, diesel oil, so on and so forth. This is just a picture of an oil refinery in Texas. So this graph is essentially showing kind of the increase in oil consumption in the United States over time. So starting from 1950 through 2010 approximately. And really there's not an end in sight at this point because, as I mentioned, there actually still is oil to be had. It's just there is an end to it. So this graphic might be hard for you to see, but and I won't go through every part of it, but it's just going back to kind of early industrial revolution in 1857, where the first commercial oil well was drilled, and then going through time, like the beginning of OPEC in 1960. OPEC stands for the Organization of the Petroleum Exporting Countries. And then talking about like the oil crisis in the 70s, where people were appalled at how much the gas cost, and so there were huge lines, and it was a shortage basically, kind of a fake shortage. And goes through time, and then this is kind of an interesting point here at 2008. OPEC has 67% of the world oil reserves, produces 40% of the world's oil. And then this important fact, United States only has 2% of the world oil reserves, uses 25% of the world's oil production, imports 58% of its oil. So to say that we're dependent on other countries for our oil is an understatement. And then once you get into the red, they're talking future projections. They think by 2020 we're going to be importing at least 70% of our oil. And 2042 to 2083, a gradual decline in dependence on oil is expected, probably because we won't have a choice in the matter by that point, is my guess. So, like I said, oil is still being extracted, and it's still a profitable thing, obviously. But they're anticipating that between 2050 and 2100, there's going to be an 80% depletion. And 2050, besides being a nice round number, you may recall from the BBC video that you watched, 2050 is when they're anticipating we'll have 9 billion people on the planet. So lots of changes happening in 2050, anticipated anyway. So the major oil supplying nations are represented by OPEC. And that primarily includes countries in the Middle East. Like the original members were Iraq, Kuwait, Iran, Saudi Arabia, and Venezuela. Additional countries came on board, ranging from Libya to Indonesia. You might notice that I did not mention that the United States is a member of OPEC, because we're not. Because we really don't have, we have a very small stake in actual oil reserves. In our country, we have to rely on OPEC to give us that oil, basically. So it's a very political and charged topic, and obviously one that we've gone to wars over, and who knows, could in the future again. And this graphic is just showing, there's lots of talk about like Keystone Pipeline, drilling in the Arctic for subarctic oil, and this graphic just shows kind of the very minimal addition that output would actually provide in the greater scheme of things. Like this little bump down at the bottom is what that drilling would provide over a 50-year period, but it's really a drop in the a literal drop in the bucket compared to what we are consuming as a country. So we rely on oil and fossil fuels in general, so not just oil, but also natural gas and coal for 93% of our energy. We rely on, of that chunk, 39% is crude oil. And these are just some other stats that we talked about. 25% of the world production goes to the United States. So another non-renewable energy source is nuclear power, which in the 1950s was kind of lauded as the next great thing until it was clear that it was actually not. We have not built any new plants in the United States since 1978, primarily because they figured out that it's not really something that people want anymore, and because disposing of the waste is really difficult. There was an incident in Pennsylvania called 3 Mile Island, where excuse me, there was a nuclear incident where there was a loss of coolant in the nuclear reactor, and there was like a stuck valve. They had to evacuate like 150,000 people. It was kind of a big PR nightmare for nuclear energy. They have found actually that they can't trace any cancers or deaths directly to the 3 Mile Island incident, but that almost didn't matter because at the time people were so terrified of radioactive waste and what did this mean? So it kind of changed people's perceptions dramatically. And then, obviously, more recently, there was the Fukushima incident in Japan after the tsunami hit and the ensuing earthquake, caused the Fukushima disaster, which is still ongoing. They're still dealing with radioactive waste leaking into the ocean. So the question is, what do you do with a worn-out nuclear power plant? You decommission it, you dismantle all of the components of the power plant, you install physical barriers, which means like you're building walls basically in the ground to prevent seepage of that waste, and also entombing the entire plant in a cement barrier, which is all well and good unless you have an earthquake and it cracks that barrier, but that's another story. So, now on to renewable energy. The most direct form is from the sun, so solar energy. And then indirect ways of creating renewable energy include wind and hydropower through moving water, burning of biomass fuels, which we'll talk about, and then geothermal energy. So this graphic is showing you solar energy availability across the globe in kilowatt hours per square meter per day. And so, not surprisingly, if you look across what would be the equator, you're going to get the greatest kilowatt hours at the equator where you get the greatest sun exposure. So, Central America, Africa, parts of India are getting the highest potential kilowatt hours from solar energy. So, obviously, it's a free form of energy, so it's kind of hard to beat when you compare that to what we're doing to get gasoline all over the world. There's no carbon emissions from it. It's very low land disturbance if you build solar panels on your roof. It's a pretty moderate form of net energy, so it's an efficient use of energy, I guess you could say. One of the obvious disadvantages, though, is if you're in a place, like, say, if you are up here in Alaska, or I don't know, down here you're not going to be getting a lot of sun. So solar powered energy is not an option all over the world. Part of the problem too is that you can't store that energy necessarily. So it's something that has to be perpetually generated. This is just another interesting use of solar energy. Basically, a huge reflective disk that acts as cooking energy for these people. And this is just a focus on solar powered cells and building them into roofs. So it's kind of a different idea because it's actually the roof itself that's solar powered. It's not just a solar panel on top of the roof. So that's pretty cool. So hydropower. We actually do a fair amount of hydropower in the Pacific Northwest region. It's the leading renewable energy source because as long as the rivers are flowing, you're going to have hydropower. That also depends on the quality and age of the dam that the river's running through. Essentially, it's just the water runs through the turbines generate electricity. Of course, there are some problems, as with any energy source. There's maintenance of the dams. There are actually methane emissions from the biomass decay in the reservoirs that come after the dam or before the dam. Excuse me. As dams age, they get less efficient because they fill with silt from runoff in the surrounding areas. And obviously, the topic near and dear to Pacific Northwesterners is salmon and really any kind of fish that rely on passage through rivers. Dams obviously create a significant barrier to that, even with fish ladders and stuff like that. But all of those things being said, it's a pretty efficient method of generating energy. It's 80% efficient. It's a long lifespan, and it also provides other things like irrigation water for agriculture and obviously reservoirs for recreational use. Another form of renewable energy is wind. It's the second fastest growing source of energy in the world. They're building wind farms in a lot of places really quickly. So there's a lot of potential for it. Also, similarly with other forms, there are downsides. This is just kind of a profile view of a wind turbine. They have to be pretty massive in order to actually function. And just as with the sun, if you don't have wind, you're not getting any electricity, right? So obviously they put these in places where there generally is wind, but the wind does not blow 24 hours a day. But this is just to show kind of the increase in potential wind energy use. And these are kind of showing the classes of wind. So if you'll notice, like offshore, Southern Oregon, Northern California, really good potential for wind energy harnessing there, even in parts of the Midwest, and certainly along the East Coast as well, offshore. Pretty much anywhere there's water, there's going to be good wind potential. So let's see. So some of the trade-offs here include, very high efficiency, low impact. There's no carbon emissions, which is good. One of the biggest kind of hurdles to harnessing wind power is that they're just not really attractive. People do not want them in their backyard. They don't want them imposing on their view. They're actually been shown to kill like thousands and thousands of birds because birds just fly into them because they weren't really planning on a wind farm being right there. And one of the most important things is you can't rely on it necessarily as you could say hydropower, because if there's no wind, you still need a backup system. And then there's biomass, and biomass is just another word for burning wood, burning agricultural waste like cow dung, animal manure, charcoal, things like that. It's more common in developing countries to burn biomass, and it does release carbon dioxide into the atmosphere. Biofuels is also something near and dear. If you're a Portlander, you can buy green fuel just about most places in Portland. Um, they use actually ethanol in some cases. They recycle cooking oil, so some cars can actually run on used cooking oil that's been obviously filtered out. Still smells like tater tots all the time, but that's not a terrible thing. It's available now. It's fairly sustainable. Um, and one of the problems is that I understand anyway is that you can't use things like biodiesel and biofuels in colder climates because it actually like solidifies in the motor and screws up your motor. So they're gonna have to figure out a workaround for that, but kind of promising. Um, so reduce carbon emissions, obviously, from using biodiesel. Um, Hydrocarbon emissions go down. You get better gas mileage. Um, they use palm oil in some cases, which that has its own set of ramifications, which I won't even go into here. But they don't include um, like the environmental costs that go into making biodiesel and harvesting the plants for biodiesel. And oh yeah, and then at the bottom, as I mentioned, it can make your engine kind of clog up because it solidifies, unlike regular gasoline. So ethanol is from corn. A lot of gasoline in the country is actually kind of supplemented, I guess you could say, with ethanol. It's potentially renewable. Um, it does have higher carbon emissions, but unlike petroleum, we grow a lot of corn in the United States, so that's something that we already have. Um, it's corrosive, so people are kind of against using it, and in some cases against having it added to their gasoline as well. So, last form of renewable energy is geothermal energy, and it has to do with harnessing the energy from thermal vents in the Earth's crust and using like the steam and the hot water to generate energy. The problem with this, though, is you can see from this map is that geothermal activity is very limited to these particular areas, which makes it not a feasible solution for kind of a big scale energy problem. But if you were to say live anywhere around here in South America, geothermal energy might be an option. And then this just focuses in on geothermal potential within the United States. So, kind of southwestern United States has pretty excellent potential for it. But as you can see, there are disadvantages to it. You're going to release carbon dioxide when you harness this energy. It's going to be smelly and loud to harness this. It's going to smell like sulfur, basically. And there's not a whole lot of sites, as I mentioned, from that map to actually get this energy. But for some places that have the potential, it's something to consider if you're looking at bringing your energy sources to a more local level. So, and that's kind of the big picture, is that there's the realization that we can't have this kind of macro view of energy reliance, and that we need to kind of bring it to a smaller scale where smaller geographic areas are relying on their own energy sources rather than, say, all of the United States relying on OPEC to provide us with gasoline. And by doing this, it's kind of politically and economically more sound, and that's pretty key. But also, in terms of this class, if you don't have to ship your oil from, say, Saudi Arabia, you're already doing the environment a favor, right? If you can rely on, say, biodiesel to power all of the cars in Portland, who knows, it could happen. It would be a better thing for communities and for the country at large. And that's it for today. I'm going to have a separate little explanation on the energy workshop that we're going to be doing. in the privacy of your own homes safely, because there is fire involved. And thanks, and email me any questions. Talk to you soon.